Hey everyone, welcome to the brand new series of Technologic. For all the new viewers out there, this video series will help you to unravel the complex technologies in the easiest possible way. So if you are new, subscribe to my channel so you can't miss them. So today we are going to see an interesting topic. Ever wonder how big companies like Google is managing and deploying billions of lines of code every day? Today you are going to learn it here. So in order to make things possible, a lot of technologies are helping Google. We are going to see one by one in this video series. The first one is called Monorepo. To understand this, imagine you are building a big skyscraper. Monorepo is like the master cabinet that manages every blueprint right from offices, apartments, shops, etc. All those blueprints in one joint folder, and that joint folder is called the Monorepo. So here's the final breakdown to make things clear and understandable. The skyscraper, in our case, is nothing but the whole Google system, which means the entire collection of Google ecosystem, which includes Gmail, Maps, search engine, etc. Code is the individual blueprints, and developers are like architects. Monorepo is like the master cabinet, the single giant folder structure that stores all the blueprints of entire skyscraper, which is actually used by the architects, but in our case, developers. But wait, in this whole process, we missed an important person. So if you are familiar with this analogy, you might have guessed it already. Yes, the chief engineer. So in this scenario, we have a build system called Bazel, the super smart chief engineer. So in our next video, we'll explore more about it. Subscribe to my channel so you can't miss it. Hey everyone, welcome to the brand new series of Technologic. For all the new viewers out there, this video series will help you to unravel the complex technologies in the easiest possible way. So if you haven't watched the previous video, I highly recommend you to check it out for better understanding of this video. So we stopped at Basil in the previous video, aka the chief engineer. To understand about it, let's take a scenario. Let's say an architect has changed a blueprint. You don't rebuild the entire skyscraper just for that change. You accommodate that change and plan the changes to its closest parts, right? The same thing happens here. Basil in our case is like the experienced and smart engineer, and it does the job without revisiting everything from the scratch. But wait, before doing those changes, it needs to know what is connected to what and then plan accordingly, right? That's what Basil is good at. Before doing any work, Basil performs a special analysis and creates its own interpretation of the blueprint. In reality, this is called as the dependency graph. It is literally a list of project nodes and the edges connected between them. You can see that in action in this website. This website has the node representation followed by the Bazel in order to manage a software. After knowing all these interconnections, Bazel can figure out what needs to change. In this process, it gets help from an amazing algorithm called Merkle Tree, which we are going to see in the next video. So subscribe to my channel so you can't miss it. Hey everyone, welcome to Technology. For all the new viewers out there, this video series will help you to unravel the complex technologies in the easiest possible way. So if you are new, subscribe to my channel so you can't miss them. And today, we're at the day 3 of understanding how Google deploys billions of lines of code every day. So in our last video, our chief engineer aka Basil has created the dependency graph. This is used to find all the interconnections in the code. So the other problem is that how does it even know if a change has occurred? He can't reanalyze thousands of documents every time a change is occurred, right? This is where the Merkle Tree helps. So here's how it works. Our chief engineer aka Basil uses special seal to lock every document. In reality, this is called as hash. The first time he sees a document, he scans it and gives it a unique unbreakable seal. This seal or hash is created based on every single piece of information in that particular file. He then combines the seal from a few documents to create a new, bigger seal for that whole batch. In our analogy, a batch about the shops get a unique seal, and a batch about the offices get another seal. Finally, he combines all the batch seals to form one master seal. Now, these seals, or as we say, the hashes, are incredibly sensitive. If an architect changes even one tiny comma, the seal breaks, the batch seal breaks, and the master seal at the very top break. This will render the whole system completely different and unrecognizable, and that allows the chief engineer to know if a change has occurred instantly, just by looking at the master seal itself. He doesn't even need to read every document, he just checks the hash, that's it. So now it knows what's connected and what was changed. But what's the final step? How does it even uses this information to do actual work and rebuild just one tiny part instead of the whole system? So in our next video, we'll see it in action. Subscribe to my channel so you can't miss it. Hey everyone, welcome to Technologic. For all the new viewers out there, this video series will help you to unravel the complex technologies in the easiest possible way. So if you are new, subscribe to my channel so you can't miss them. And today, we're at the day 4 of understanding how Google deploys billions of lines of code every day. So in our last video, our chief engineer aka Bazel has found a way to detect the code changes easily by using Merkle Tree. Now it's time for it to take the changed code in and rebuild only those changed parts instead of rebuilding the entire system. So how does he do that? It uses two things, the dependency graph and caching. When an engineer changes the code in a file, the hash changes. Bazel sees that new hash and look at its dependency graph. It finds the changed file on the map and follows the connection line upwards to see every other part of the code that depends on it. This creates a small specific list of things that now need to be rebuilt. For any part in the system that was not affected by the change, the hash of it will stay the same. Bazel finds those unchanged files in the cache and reuses the document instantly. This is called cache hit. For the changed files and the file depending on it, their hashes are new. Bazel sees that they are not in the cache, which is called as cache miss. Only for those few parts, it will perform the actual slow work of recompiling. This is how Bazel finds the code changes quickly and recompile them without building the entire system. So if you like this video, share it with your friends and subscribe to my channel for more interesting videos like these.